Hey guys, welcome to this new video. This one is paper 1-2 of February-March 2021 for A-level math of paper 1. Now with that being said, let's move on to questions number 1. Okay, so let's see what do we have here. So here we have to find the first three terms of this expansion. Let's do this. So this is pretty easy, as we have seen many times before. The first three terms will be, the first term is 5, choose 0. Here we have 1, and here we have x. And this is 0, this will be 0. 5 minus 0 is 5. That's the first term. Now continue is 5, choose 1, because after 0 we have 1, right? And here it is 1, and here we have x. If that is 1, that will be 1. This is 5 minus 1, this is 4. And finally, the third term of this expansion, that will be square and 3. Now let's simplify and find the value of each term. So 5 choose 0 is 1 times 1 power 5 is 1. That should be 1 plus, so 5 choose 1 is 5, right? Let's check, right? And then we have 1 power 4 is just 1 times x, plus 5 choose 2 should be 10, but let's check. That is 10 indeed. So 10 times 1 times x squared. That will be 1 plus 5x plus 10x squared. So this is the first three terms of this expansion. That is part A of the question. Now for part B, find the first three terms of the other expansion, this one. So same steps. We'll have 6, choose 0. Here we have 1, and here we have minus 2x. This is 0, this will be 0 as well. This will be 6. Then we have 6, choose 1. That will be 1 minus 2x. That will be 1 and 5, and then we have 6, choose 2, 1 times minus 2x, that will be power 2, because here we have 2, that will be 4. Now let's simplify to see what we will get. So 6 choose 0 is 1, that should be 1 as well, this will be 1, plus 6 choose 1 is 6 times 1 times minus 2x, plus what is 6 choose 2, let's see, 6 choose 2, that will be 15. It is combination 2 actually, but it's the same meaning. That will be 1, that will be 4x squared. Right. Simplify. 1 is 1. This will be minus 12x, and this will be plus 60x squared. Always double check. 15 times 4, that will be 60 indeed. Okay, so that will be the first three terms of this expansion in ascending powers of x. Okay, that will be part A, part B. Now let's move on to part C. So here we have to find the coefficient of x squared. Now first thing first, what does it mean to find the coefficient of x squared? So basically we have to know the coefficient of x squared is basically the number or the value in front of x squared. This is called the coefficient of x squared. So in this expansion. Now obviously, why is this question part C? Is because we have to use the previous two parts of the question to find this answer. So let's first replace these expansion by the value we have found from part A and B. So this we have seen, it became 1 plus 5x plus 10x squared. And this we have seen, it became 1 minus 12x plus 60x squared. Now in this expansion, we only care about the value in x squared, so we don't need to really expand everything, but if you want to, that is okay as well. But the idea is that you have to choose which one do you want to expand by. For example, if you were to expand this, you will have, say, the first term multiplied by the whole thing, right? So minus 12 plus 60x squared plus 5x times 1 minus 12x plus 60x squared, and finally 10x squared multiplied by 1 minus 12x plus 60x squared. So that's the idea behind expanding this. It will be something like this. So now we have to choose. 1 multiplied by what will give you something in x squared. So 1 multiplied by something in x squared will give you a value in x squared. Right. Plus, here we have x already, so we have only need to multiply by something in x to give you something in x squared. So plus 5x multiplied by minus 12x. That will be the other term. And this one, since we have x squared already, we only need to multiply by a constant to find the value in x squared. Because if you multiply by the other ones, it will be x cubed, x power 4. So we don't need that because we only care about the coefficient of x squared according to the question. Now simplify, that will be 60x squared minus 60x squared plus 10x squared. So these two will cancel out, and this will be 10x squared. But your answer is only the coefficient, the value in front of x squared. So this will be your answer, which is the coefficient is equal to the value of 10. And that is your question number 1. Let's move on to question number 2. So here we have to solve the equation. Solving means to find the value of x, right? Now we have to use a suitable substitution. Now you can choose anything that you would like. You can try one by one. It will be up to you, right? So for here example, I can choose. Let's say I can try let u equal to the base. That will be 2x minus 3 this. For example, right? I don't know what to choose. Let me choose that. You will have u minus 4 over u minus 3 equal to 0. Now, because we have a denominator here of u, multiply everywhere by u, so we can eliminate the denominator. So you will have u squared minus 4 minus 3u equal to 0. Right. Now simplify or rearrange, that will be minus 3u minus 4 is equal to 0. Now we can factorize, so that will be what? That will be u times u. 4 is 4 times 1. Minus 3 is minus 4 plus 1. Right, to get minus 3, we have to have minus 4u plus 1u. That will become minus 3u. Now simplify, so u has to be 4 and u has to be minus 1. Now again, we're not trying to find the value of u here. We are trying to find the value of x. So we place back the main substitution over here. You will have 2x minus 3 squared. That will be 4. And here we have 2x minus 3 squared. That will be minus 1. Okay. Now in this case, I don't think we do complex numbers yet from paper 1. So in this case, that would not be valid, because if you were to send this 2x minus 3, that will become square root of minus 1. And as we know, this is invalid for calculation. So root of minus 1, that will be math error. At least for paper 1, we don't deal with complex numbers, I believe. Now for this one, let's see. We have to send this one over there. That will be plus minus root of 4. That will be 2x minus 3 plus minus 2. So we have two possible answers. So let's see which one can we use. So you will have 2x minus 3. That will be 2. Or 2x minus 3. That will be minus 2. So simplify. 2x, that will be, send this over here, become 5. X will become 2.5. 2x, send this over here, become 1. X become 0.5. So these two are the values of x that we have for this equation. So solving this equation using a suitable substitution. Now again, you could have chosen something else. For example, you could have let u be 2x minus this as well. It should be giving you the same answer as well. Should not be any problem. So that will be your question number 2. Let's move on to question number 3. So here we have to solve the equation for the value of theta between 0 and 180. Okay, that's the domain for theta. Now one by one, as we can see here, what is the value of tan theta? So we understand it is sine theta over cos theta. So let's try to simplify our main fraction, right? So that's the first thing we can do. So we can cross multiply. You will have tan theta plus 2 sine theta is 3 tan theta minus 6 sine theta. Right, that's the first step we can apply if you want to. And then we can replace now. We have tan is equal to sine over cos. So sine theta over cos theta plus 2 sine theta is equal to 3 times sine theta over cos theta, right? And then minus 6 sine theta. Now, again, as you can see, we have the same base on both sides, or we can send this to one side if you want to. Okay, so in this case, let me send this one over here. You will have 2 sine theta plus 6 sine theta, and I will send the other one to this side, so we have the same base on each side. That will become minus sine over cos theta. Let's try to simplify to see what happens. So here we have 8 sine theta is equal to, that will be, of course, this is 3 sine, so let's combine them first. That will be 3 sine theta minus sine theta over the same base. Now simplify, it will become 8 sine theta, that will be 2 sine theta over cos theta. Now one thing we can do, we can obviously cross multiply, right? So we can send the value of cos to the other side. You will have 8 sine theta cos theta minus 2 sine theta is equal to 0. Send this over here, right? Now we can divide by 2 everywhere because this is even. This is even. We want to simplify. That will become a 4 sine theta cos theta minus sine theta. Now as you can see, sine theta is common in those two. We can factorize that. So sine theta, that will become 4 cos theta minus 1 is equal to 0. Now we can solve this equation one by one. So for the first one, we have what? We have sine theta is equal to 0. And here we have 4 cos theta minus 1 is equal to 0. So let's solve this one first. This one will be theta has to be sine inverse of 0. That will be 0. You can check, right? Sine inverse of 0, that will be 0. But also it will give you the other value, which is 180 in the other quadrant. Also will be 360 as well, because 0 is the same as 360. However, if you go up here, the value of theta can only be between them but not inclusive, so we will not be taking those values. Okay, so in some case, what if we had this equal sign? So in that case, you will have had to take those values, but in this case there's no need. Now let's solve for this one. First, make cos become subject. That become 1 over 4. As you can see, cos is a positive value. It will be in the first quadrant and in the fourth quadrant. This is 360 minus theta, and this is just theta for your answer. So let's see what values do we get for this one. So that will be theta has to be cos inverse of 1 over 4. That will be 75.5, right? That will be degrees. Now let's check if we have the other value will be 360 minus 75.5. That should be 284.5. However, this value will be outside of the domain, so eventually theta can be 75.5 degrees as your answer. Okay, and this is your question number 3. Let's move on to question number 4. So a line has equation this. This is a straight line, and a curve have equation this. This is a minimum curve because we can see this is 1 here. You'll have a shape something like this. Right, that's the first thing we can kind of think at the back of your head. Now where k is a constant, okay, great. Now we have to find the set of values of k for which the line and the curve have 2 distinct solutions. So what does this mean? So whenever you see 2 distinct points of intersection, we think about b squared minus 4ac has to be more than 0. That's the first thing we actually think about. Now let's see what can we do now. So again, you can see the line has an equation and they have points of intersection. So whenever you see intersection, you see meets or cuts, we have to solve a simultaneous equation. So y equal to 3x plus k is my first equation, and this one is y equal to x squared plus kx plus 6. That will be my second equation. So because here we have y, let's substitute them in each other. So on one side you will have 3x plus k is equal to x squared plus kx plus 6. Now we have to rearrange. Let's send everything to one side. You will have what? X squared plus kx minus 3x plus 6 minus k is equal to 0. Now simplify. X squared plus k minus 3x plus 6 minus k. So if you observe, this is your value of A, B, and C. Now we just have to replace back in this equation. So b squared minus 4ac. B squared is square minus 4 times A and times C, more than 0. So simplify, that will become k squared minus 6k plus 9. That will become minus 24 plus 4k more than 0. Simplify one by one. So let's see what do we have here. That will become what? K squared. So k squared is k squared. And here we have minus 6 plus this will be minus 2k. And this will become 9 minus 15. That should be 15 minus 15. Oh, sorry. Let's see what we have. Yeah, indeed. Let's see, 24. That should be minus 15. So I was right. Anyways, always double check with your calculator. Now, once we have this, we have to check the answer by using the critical values. So critical values will be what? Will be the same equation. Equate that to 0. Okay. Then we have to factorize. That will be k times k, 5 times 3, right? To get minus 2, we have to have minus 5 plus 3. So k can be the value of 5 and k can be the value of minus 3. Now, this is not the answer yet. We have to draw the graph. This is my value of 0 here, right? And since the shape of the graph is this shape, right? Because it is plus 1 here, the coefficient is plus 1. So we have this shape right here. This value are the critical values. This is the value of minus 3. This is the value of 5. Now, as you can see, we need the values of k to be more than 0. So above this one, above the 0, it should be this and this. So from this, we conclude that k has to be less than minus 3 and k has to be more than 5. This will be your answer for question number 4. So let's move on to question number 5. So in the diagram, we have a graph of y equal to f of x is shown with a solid line. So this is my initial graph, y equal to f of x. Okay. Now the graph is shown with broken lines is a transformation of the graph y equal to f of x. So something happened to this one, it became this one. Transform into the other one. Now part 1, describe fully two. So we have two transformations of this that has been combined to give the resulting transformation. So we have two things happening to this one to make this become this. So by observation one by one, you can see that we have to have, first thing is we have to move. So move 1, 2, 3, 4. So that's the first thing, we have to move 4 to the right. That's the first thing that happened. So let me write this down. The first will be a translation with column vector, if you want to write that, if you want to. That should be a value of, since it is to the right, in this case, for translation, it will be plus 4, and then 0 will be, so because we did not move up or down for the first transformation, this will be why it is 0. It is only moved to the right by plus 4. Or you can write it will be so direction, so you can write also in a direction of y, we have moved 4 units. That will be the first transformation. So that is part 1 either way. That should be something like this, a translation for the vector this. You have to provide this as well for the part of the answer. Now for part 2, let me actually draw this now, because so we can have a look to see exactly what happens. Let me find a ruler. So right now, after moving this to this side, this will be what? This will be something like this. This will be here, and this will be here. Right, that's the first idea. After the first transformation, our f of x will be right here. Now, how can you make this become this? As you can see, the size has changed. So in this case, we only have a stretch to work with. Now, when we deal with stretch, we know it is a stretch, right? That's the first thing we know. Because the size has changed, we know it is a stretch. That's the first thing we can write. Now, when you describe a stretch, we also have to provide the stretch factor. So pretty easy. So from this point, we can just choose, for example, choose this point to work with. This is the object, and this is the image. So distance from the x-axis will be 1. Distance from this one to the x-axis will be 3. So 3, and this is 1. So the stretch will be what? Stretch factor will be this whole thing, 3, divided by the initial thing, 1. So now you can also check, for example, let's use this one as the object. So this one, there's no need to go further. This is just a way to double check if this is okay or not. This is what? So let me use this one. Why not? Same thing. So same thing. This one, same thing. So in this case, the distance will be what? Distance will be 1, 2, right? 2, and distance here will be 6, right? So 6, as you can see, 6. So stretch factor will be what? You have to find this one will be 6 over 2. That should be 3. Same thing for here. This is 2 and this is 6, so it will be 6 over 2, 3. So now we can safely write it is a stretch with stretch factor equal to 3, and also we have to provide the invariant line. Invariant line is the x-axis, because as you can see, every time we measure the distance, we are counting from the x-axis. This is why it will be called the invariant line. So here we count 1, 2 from the x-axis, and here 1, 2 till 6 from the x-axis. So this line will be the invariant line whenever we have to describe a stretch. So just to confirm again, when you describe a stretch, we have to first write down the type of transformation. We have to provide the stretch factor, and we also have to provide the invariant line. Now that is one way of describing a stretch. You can also write in the direction of y-axis if you want to do that. And that should be two single transformation applied to f of x to give you this line, right? That will be part A of the question. So as you can see, step by step, you have to find the answer by elimination as well to think about what is possible and not. Now for part B, we have to state y in terms of y, f, and x, the equation of the graph with this. So at first we had y equal to f of x. That is the initial graph. Now first thing happen is, number one, we know that it is moved to the right by 4 units. So to the right means along the x-axis, right? Right or left will be along the x-axis. So we know that by applying 1, our new equation will be y equal to f x minus 4. So in this case, it will be kind of counterintuitive. You see, when you move to the right, it will have to be minus 4 inside. That's how we rewrite this, okay? I understand it is kind of counterintuitive because usually when you move y on the y-axis up or down, it will be plus, but in this case, it has to be minus. That's the first step. Now, number 2, we have seen that we have applied a stretch of 3. So, and a stretch of 3 will be along the y-axis. So this is why we have to write y equal to 3f minus 4. This will be my new equation in terms of y, f, and x. Now, this can be very tricky now. So how do you describe stretch along the x-axis? So I guess I'll leave that to you guys to think. How would you write the value for stretch factor or stretch for moving along the x-axis? It will be different than this one. So you have to think. I will leave that to you guys in the next videos. But for now, one by one, first you move to the right by 4. So if you move to the right in this case for the x values, it will be counterintuitive. We have to minus 4. That's the first step. Now we understand it. We're moving up again by 3, which is the stretch factor. So we have to write 3 outside of the function. That is question number 5. Now let's move on to question number 6. So a curve is such that dy by dx equal to this, and A is a point on the curve, okay? A point is moving along the curve, and at A, the y value of the point is increasing at 3 units per second. So dy by dt at that, it is 3 units per second. So that is dy by dt. Okay, let's move on. So part 1, we have to find the rate of increase of A at of the x value at the point. So we have to find dx by dt at that point. So how would you find this? We have to form an equation. So first, let's define dx by dt. That will have to be, here we have dx on top, and here we have dt at the bottom. Right. So how can we define this? So how are they connected with each other? So as we can see, we have to do what? We have to connect them by something. So here we have dy, and here we have dy, right? Because that's the only thing we can use to connect them with each other. Now, this we know already. This is 3. But here we have to find this one. So before you find dx by dy, let's first find, because here we have dy by dx, so let's use this one. So let me use dy by dx. Is 6 over 3x minus 2 power 3. Now from this we can write dx by dy. It will be, flip this upside down, that will become 3x minus 2 power 3 over 6. Right. Now we cannot simplify because we are finding the value at the point A. The point A is given to you by 1 minus 3. This is my value of x, this is y. So as you can see, we have to replace the value of x by 1. So dx by dy at the value of x equal to 1. That will be 3 times 1 is 3 minus 1 minus 2 is 1. That will be 1 over 6. Now just replace back in the main equation. So dx by dt has to be dx by dy will be 1 over 6 multiplied by dy by dt, that should be the value of 3. That will be 1 over 2 as the answer. Okay, so let's write this down. So that will be 1 over 2 is 0.5 units per second as well for the value of dx by dt for the rate. That is part A of the question. Let's move on to part B of the question. So here we have to find the equation of the curve. So we have to understand, what are we trying to find? We are trying to find the value of y. So how would you find the value of y? So we understand that y has to be integration of dy by dx. So that will give you integrate 6. We can rewrite dy by dx as, so we can send this up, that will become 3x minus 2 power minus 3 by dx. So let's rewrite this. So I will have something, let me take out the value of 6. You will have 3x minus 2 dx. That will become 6. That will become 3x minus 2. So first thing, we have to add 1 to the power. That will become minus 2, sorry. Then divide by the power. Then divide by dy dx of the value inside. That will be 3. Right. And then plus c, of course. Now simplify. This will be minus 6. So minus 1 remain, right? Minus 1 here. So you will have minus 1 over the value of, that will be 3x minus 2 square. But if you bring this down, become positive 2. Then of course plus c for the value. Here it is y. Now of course we have to do what now? We have to find the value of c. So we have to use a passing point, as we have seen before. It is 1 and then minus 3. Sorry, that will be x and y. Replace in the equation, so y is minus 3. X will be the value of 1. That should be 3 times 1 minus 2 is 1 square is 1, right? Plus c. So c has to be minus 3 plus 1. That has to be minus 2. So in the end, the value will be what? Y is equal to minus 1 over the value of 3x minus 2 minus 2. Okay, so that will be part B of the question. For finding the equation of the curve, that will be question number 6. Let's move on to question number 7. So here we have functions f and g are defined by the following function. Okay, good. Part 1, find f of x in terms of this. So we have to complete the squares and state the range of f. Okay, so let's do that. So one by one. So let me first write this down. F of x is given to you by x squared plus 2x plus 3. Now, first thing we have to check is the coefficient of x squared. If this is 1, we can move to the next step. So this is good, we move to the next step. So I'll first write x squared plus 2x, leave some space, and write plus 3. Now we have to add a value here, plus the value will be, here we have 2, we have to write 2, then divide by 2 square. Now, when you add something, you have to also minus the same value, so your equation does not change, if that makes sense, right? So this will become what? So now we have to look at this, and this way. So this will become x here, we have plus, that will become plus, and here we have 2 divided by 2 is 1, that will be 1, and here we have square. Right, and here we have plus 3 minus 1 square. So it become x plus 1 square plus 3 minus 1 is 2. So now by comparing, you can see this is x plus a square plus 2. 2 is b, right? So this is your complete square form for f of x. So that is, f of x can also be written as x plus a... Okay, let me write this down again. I don't know why I always copy the same equation, which will be x plus 1 square plus 2. Now we have to find state the range of f of x, the range. Okay, the range means the y values. We have to look at the graph at this point. So we can see that, here you go, f of x is defined for the value of x less than or equal to minus 1. So as we have seen, by having converted my equation to this, we understand that we can use this to find the shape of the graph. For example, here I understand this is my x and y, right? For example, this is x, y. Now, because the value here is positive, I know I have a minimum value. Now this is my minimum value at the end. It happens when this is equal to 0. So x plus 1 is equal to 0. It happens at x equal to minus 1. At the point x equal to minus 1, let's say it should be somewhere over here, minus 1. My minimum value will be 2. So it will be right here. So the idea is that my graph will have a shape. Let me use blue color here. It will be something like this. Keep going on. This is the shape of my graph, right? So now we have to state the range. So the range means the y values. As you can see, the y values would always be more or equal to the value of, this is the value is 2. So state the range will be, so now we have to express range in terms of y or in terms of f. So we can write y has to be more or equal to the value of 2. You can see always more or equal to the value of 2 will be the range of your f of x. That will be question part A. Now let's move on to part B. We have to find an expression for f inverse of x. So one by one, we have f of x is equal to x plus 1 square and plus value of 2. To find the expression for f inverse, so obviously first y will be x plus 1 square plus 2. Simplify y minus 2, that will be x plus 1 square. X plus 1 will be plus minus y minus 2. Now let's see, we have what? X will be minus 1 plus minus y minus 2. Now obviously in the end you have to express f of x. It is in terms of x. That will be minus 1 plus minus y minus 2. Now you have to find the one that fits. It will be minus 1 plus, so x minus 2. So that will be the expression for f of x in terms of x. That will be part B of the question. So now we have to solve the equation. So we have to find the value of x. So let me write down the value of g of x. So g of x was found to be, from part 1, it is 2x plus 1, that is g of x. And then f of x we have seen it is x plus 1 square plus 2. Now let's solve this. So we can first either find this, what is this value right here? That will be g of f of x. That will be 2 times f of x will be x plus 1 square plus 2 and plus 1. That will become 2x plus 1 square plus 4 plus 1. That will be what? So we have this value right now. Let me just rewrite this. We have 2, then we have x plus 1 square plus 5. That will be g of f of x. Now replace back in your main equation. You will have on one side, you will have 2 x plus 1 square plus 5 has to be 13. So x plus 1 square 2 here. So that will be what? Let's see. 13 minus 5. That will be 8. And x plus 1 square will be the value of 4. Now, pretty easy. X plus 1 has to be plus minus 2, because that will be what? As we know, x plus 1 has to be plus minus root of 4. X has to be minus 1 plus minus 2. From this, we can conclude that x has to be, so minus 1 plus 2 has to be 1, or x has to be minus 3. But now again, we have to look at the range where they are defined by. As you can see, we have what? Here we have f of x. So we have this value for the domain of those two. So here we have g of f of x, right? So we know the domain of the value of f of x does fit into g of x, so that is okay, because as we have seen here, y has to be more than 2, so this is okay, this is good. Now we just have to look at this one, which is minus 1. That's the minimum we can go to. So because of that, minus 1, right, we cannot take this value, so x has to be 1 as your answer. Okay, so the main idea is that you will have to compare those values. Because the value of f of x will be inside of g of x, so we look at the range of f of x. We realize the range has to be more than equal to 2. So that is okay. It is the more value, the value on the positive side. So we have to look at this one now. This one is the cage closing the f of x. The cage value is x has to be more or equal to minus 1. This is our main condition. Bring this back to the values here. Now we compare with those two values, which one will be in this. So this will be on the left side of this. So in this case, it will not be possible. So we can only take this one as your answer. That will be your question number 7. Now let's move on to question number 8. So the points A, B, and C are on the circumference of a circle. So part 1 is to find the equation of the circle. Now, this question, there's many ways of doing this question. So one of the ways is really just to go full force solving the simultaneous equation. So let's see one thing. We understand that x minus a square plus x or y minus b square equal to r square. That will be my equation of a circle usually, right? But either way, let me find the other way we can do this question more easily. So I would advise to draw something to help you out to understand what's happening, right? So let's see, here we have what? The y-axis, and here we have the x-axis. So this is just to help us to understand what is happening, so we can understand how to solve this question. So it is clear that the circle will be somewhere over here. Let's say, for example, it's somewhere over here. I don't know. It should be somewhere over here according to my points. Right. Circle has a center, obviously, right? Somewhere over here. This is my x and my y. Now the first point given to you is 7, 1. Let's say 7, 1 is somewhere over here. Let's say somewhere over here. 7, 1, somewhere over here. Why not? This is 7, and this is the value of 1. Now the next point here we have 7, 9. Let's say 7, 9. So because this is 7, it has to be straight along this line. So it should be somewhere over here. 7, 9. Let's say this is my value of 9. This is my point A, my point B. And last one we have 1, 9. 1, 9. Let's say 1, 9 should be 1 should be somewhere over here. say 1 here, and 9 should be somewhere, let's say same line as this. This is 1, this is the point C. Okay, so now you can see this is approximately the positions of the point on the circle. So we have to use that to find the equation of the circle, right? So let's see. To find the equation of a circle, we understand that we have to find what? We have to find the center and the radius to be able to find the equation of a circle. Now, the one trick we can use here, if you observe, we can do that. So let's say we were to join the line AB. This will be a straight line, right? Because they all have the x value of 7. That will be my straight line AB. That's the first thing I can know. Now, the perpendicular, or the perpendicular bisector of AB will be a line passing through the midpoint of AB, somewhere over here, right? And it will be this line. So the first thing I can say, what is the equation of this line, right? It will be, because I know this is a straight line, this value here is 9, this value here is 1, the distance here is, it is 8, so halfway 8 will be 4, so we count 1 plus 4 has to be 5, y equals to 5. That is my equation of this line. Okay, now what's next? Now I can use these two. By joining those two, right? Same idea, because I know this is a straight line, the value in between has to be what? Because this is distance 6 divided by 2 is 3, so here 1 plus 3 has to be 4. So my equation of this one has to be x equal to the value of 4. Now as you can see, they both meet at the center of the circle, so the circle center has to have the point, x value is 4 and the y value is 5. Okay, and this is my center of circle. So that's one way to find this center. Obviously you can always solve a long simultaneous equation to find that, but this is a good way to find this pretty easily. So we just have to understand that the perpendicular bisector, by joining those 2 points, they will pass to your center. So let me write this down. So we just have to understand that if you have 2 points on the circle, the perpendicular bisector of the 2 points on circle has to pass through the center of the circle. That's the main idea behind this. As you can see, first step was to find the perpendicular bisector of AB. So first join AB, it is a vertical line. Now we find the bisector, the perpendicular bisector. It passes to the center. The equation was this. So same step applies here, then they both meet here, and this is the center given to you. Okay, so now we know that. What do we know? Replace back in your equation x minus, this is the x value, that will be 4 square, and here we have the y value, so that will be y minus 5 square equal to r square. So we still have to find the value of r square. To find that, we just use one point on the circle. Let's use the point A. 7, 1. This is my x value and my y value. Replace back here, you will have what? X minus 4 is 7 minus 4 is 3 square, plus y, y minus, this is 1 minus this will be minus 4 square, has to be r square. R square has to be the value of 9 plus 16 has to be 25. Right, from this you can realize that r has to be root of 25, which is equal to 5. This is the radius of the circle. But either way, this is not very important here. The idea is that the equation was found to be x minus 4 square plus y minus 5 square has to be 25. This is my equation of the circle. By using this method of graph to understand that, by finding the perpendicular bisector of 2 points, we know it will meet at the center of the circle. That is one way of doing this question. The other way is to go one by one, replacing the values of the points in this equation. So you will have 3 equations, and you can solve simultaneously as well to find the answer. That will be part A of the question. Now let's move on to part B of the question. So here we have to find the what? Find the equation of the tangent to the circle at the value of B. So Right now we have what? We have the circle, for example. If you draw this, this is my center here. Center was given to you by 4, 5, right? Was found to be 4, 5. And the point B, it was somewhere over here. B was given to you by 7, 9. Now we have to understand what are we trying to find. We're trying to find the equation of the tangent, so about of this line passing through the point B. Now again, we can play with the diagram to understand what do we need to find. So if you join this to the center, B to the center, we have this line. Now, to find the equation of a tangent, which is a straight line, we understand that we have to find the gradient of tangent. That's the first thing we need to find. Now, according to the diagram, to find the gradient of this line, this is my tangent, we must first find the gradient. Let's call this point, let's give it a name D. So we have to first find the gradient of dB. So how would you find this? Let's find this, m dB. That will give you, using the formula y2 minus y1. So 9 minus 5 over 7 minus 4. That will be 4 over the value of 3. Now from this we can conclude that gradient of tangent will be what? Will be minus 3 over 4. Okay? So now if you have the gradient and if you have the passing point, we can find the equation pretty easily. That will be what? So this will be 7, 9. This will be x value, y value. So y minus 9 over x minus 7 has to be minus 3 over 4. Now we just have to cross multiply. That will become 4y minus 36 minus 3x plus 21, right? Now what's next? We have to send this to the other side. That will be 3x plus 21 plus 36. So finally 4x equal to minus 3x plus 57. And this is the equation of my tangent of the circle at the point B. This is the easiest way to find this equation, and that will be the question number 8. Let's move on to question number 9. So the first term of a progression is cos theta. Okay, so A is equal to cos theta. The first term is cos theta. That's the first thing we know. Now theta is between the values of 0 and pi by 2, which is 0 and 90 degrees. That's something I guess good to know. For part A, find the case where the progression is geometric. So now we know the progression is geometric. The sum to infinity is this. So sum to infinity is given to you by 1 over cos theta. Okay, so the first thing we do is that whenever we know the type of progression we have, let's first write down all the equations that we can use. So for a geometric progression, we know the n term is given to you by a r n minus 1, and the sum to infinity has to be a over the value of 1 minus r, for r has to be less than 1, the modulus of r obviously. Okay, so now replace 1 by 1, so we know that a has to be this, and the value of this is given to you, so we have to use this somewhere, right? Sum to infinity is 1 over cos theta, has to be a is cos theta over the value of 1 minus r. Now let's solve for the value of r, right? Let's see. What can we do? So we can cross multiply, for example. You will have what? 1 minus r has to be cos square theta. So r has to be 1 minus cos square theta, which is sine square theta, right? That's the first thing we can derive from that. Now, moving forward, we have to find the second term. When the value of n is 2, it is equal to a, r, n. So 2 minus 1 will be 1. So we have to find this. A is given to you by cos theta, and r is given to you by sine square theta. So this is shown as required for part 1 of the question. Okay, that is good to go. Now for part 2, we have to find the sum of the first 12 terms when theta is this value. So let's see. We know a is equal to cos theta, but cos of 1 over 3 pi, that will be half. So my first term is half. Now following this, the value of r is equal to sine square theta. That will be sine 1 over 3 pi square. Now what is sine 1 over 3 pi? So I guess let me try. So sine 1 over 3 pi will be 180 divided by 360 degrees. That will be this. Square will be this value, 0.75. So let me try in radians as well, just to show you guys. So so we have sine pi by 3 and then square. That will be 0.75. Okay, so we have these two. We can find the sum of the first 12 terms. Now first we have to write down the equation. The sum of the first n terms is given to you by, we have a 1 minus r power n over the value of 1 minus r. Replace. Let's see what you have. A will be half, and you will have 1 minus the value of r is this. And now we have 12 terms, right? So n has to be 12, so that will be 12 here, and 1 minus 0.75. Okay, so one by one, simplify. So here we have to give your answer correct to 4SF, so we have to keep that in mind as well. So 1 minus 0.75 power 12 divided by 1 minus 0.75 times half. So that will be 1.93667. So let's double check again. So we have 1 minus 0.75 power 12 divided by 1 minus 0.75, that will be this, times half, that will be this. Okay, good. Now we have to give the answer correct to 4SF, so we have to 1, 2, 3, 4. Look at this value. Is this value more or equal to 5? The answer is yes, so we have to add 1. That will become 1.937 for your answer. Okay, and that will be the question part A of question number 9. Let's move on to question part B. Now for the case when the progression is an arithmetic progression, so now we know the type of progression. Let's first write down the formulas we know for this progression. The nth term is given to you by a plus n minus 1 times d, and the sum of the first n term is given to you by half 2a plus n minus 1 times d. Okay, now we know what the first two terms are, again, cos this and this. Okay, good to know. So the first term, a, is cos this, and the second term is cos this sine square this. That is given to you. Now we have to use those values to find what? To find the 85th term when the value is this. So let's first replace to see what happens, right? So when the value of theta is 1 over 3 pi, we know a has to be the value of what? Cos of 60, that should be half, or 0.5 if you want to. And the second term has to be what? Let's see. So cos of pi over 3, then we have multiply by sine square, so we have to square the value, so that will be sine of pi over 3 square. That will be 0.375 for the second term. So we know these two for that. The question is to find the 85th term. So term 85 is what? So when the value of n is equal to 85, we have to find the term, right? That's the main question we are trying to solve here. But now, as you can see, we have the value of a. We have to still find the value of d. So let's do that, right? Replace second term when n is equal to 2. We have this value. So let's replace in this equation. You will have 0.375 is equal to a is 0.5, plus n minus 1 is 2 minus 1 is 1, times d. D has to be 0.375 minus 0.5. That will be what? Minus 0.125. Okay, that is D as we have seen. Now we can find this one pretty easily. T85 will be what? When the value of n has to be 85. Let's see what do we have for this answer. So replace back in the equation. So that will be A is given to you. So in this equation, obviously, A is given to you by 0.5, as we have seen here. And plus n minus 1 is 85 minus 1 is 84 times D. D is minus 0.125 for the value. Let's solve one by one to see what happens. 0.5 plus 84 times the answer. That should be minus 10 as your answer. And this is the question number 9. Let's move on to question number 10. So the diagram shows the sector ABC. As you can see, A, B, and C is part of a circle of radius A. So this is A. This also would have to be A because it is the radius of a circle. Right, that is A as well. Okay, now the points D and E lie on AB, so D and E right here, and AC respectively, are such that AD equal to AE, so these two are the same and they have the value KA. Okay, well, K has to be less than equal to, less than 1, sorry. Now the line DE divides the sector into two regions which have equal areas. So basically, if I were to, let's call this number 1, and let's call this number 2. So the idea is that area of number 1 has to be equal to area of number 2. So that's how this line DA divides the sector into two equal pieces. So now again, we have to keep in our mind that we have to use this thing to find the following answers, right? So for part A, for the case where the angle BAC is equal to 1 over 6 radians, find K correct to 4SF. So in this case, BAC will be this angle right here is equal to 1 over 6 pi radians. Okay. So we have to find the value of K. So, okay, so that's pretty straightforward. We just have to use this information, right? So let's do that. How would you find the area of number 1, which is A, D, and C? As you can see, it is a triangle with these two sides and the angle in between. So whenever we have this condition, we can use the sine formula. So area of number 1, that will be what? Half times the sine of the angle in between, which is BAC, and times the two sides, which is on the two sides of the angle, which is AD and AE. So let's replace. Half sine of 1 over 6 pi. AD will be KA times KA. So simplify. Half. What is sine of pi? So sine of pi over 6. That will be 0.5. So it is half. And Ka times Ka will be K square and A square. So that will give you 1 over 4 K square and A square for the area of number 1. So that's the first thing we have. Now we have to find the area of number 2. So how would you find area of number 2? So by observation, we have to first find the area of the whole thing and minus the area of number 1 to get the area of number 2. So let's do that. To find area number 2, we have to take the whole thing, so the whole, which is the sector A, B, and C. That will be half radius square of the angle. Half radius is given to you by Ka. Sorry, radius here is not K, I apologize. It is the whole thing, which is A, not K. So it is A. And then we have the angle will be 1 over 6 pi square. So simplify. That will be half times A square times 1 over 36 pi square. That is the sector ABC. Now let's move on. So we have to find the area of number 2. So as we have seen, area number 2 according to the diagram has to be the whole thing, which will be 1 over 7/2 pi square A square minus area from number 1, which is 1 over 4 K square A square. That is my area number 2. if that makes sense, right? So let's have a look one more time. To find this area number 2, which is this one, small part, we take the whole thing, everything minus the top part, which is number 1. So whole thing will be area of sector, which is this formula, half r square, which is the radius square times the angle. So here we have, I don't know why I did this. This is wrong here. Should be 6, not square. So my mistake. Let me correct this for you guys. So this should be 12, not 72. So that's a very silly mistake. So I hope you guys don't make these kind of mistakes in your exam. So always double check your answers. That will be this, and then minus the number 1 to find this one only. Now, we do know that number 1 is equal to number 2. So number 1 is what? Is 1 over 4 k square a square is equal to number 2 is 1 over 12 pi square a square minus 1 over 4 k square a square. Now I can first send this one over here. You will have, this is the same thing, that will be 1 over 2 k square a square, that will be 1 over 12 pi square a square. Now as you can see, a square will cancel on both sides, and this we can just send 2 over here. That'll become k square 1 over 6 pi square. K will be what? Pi square divided by 6. Root of that should be 1.2825499. But your answer have to be correct to 4SF, so k has to be 1.283. K has to be less than the value of 1. This is not the right value. Let me see where I made a mistake. So, okay, I see it now. So basically the idea was that here we don't have square, so we have to remove the square from here as well. Okay, so here we don't have a square, we don't have a square, we don't have a square value. So this is not the right value. That will be 1 over 6 times pi will be this value, and square root of that will be 0.723601254. But now you have to give your answer to 4SF, so k has to be 0.7236 4SF. And that is part A of your question number 10. So now let's move on to part B of the question. So for the case where the angle BAC is theta radians, and theta is between 0 and 90 degrees, right? It is given that we have this ratio is more than 1, which is theta divided by sine theta. Okay, it is more than 1. Now using this, find the possible values of k. Okay, so let's see. So same thing again. So the idea is that area of number 1 is equal to area of number 2. So as you have seen before, area number 1 is equal to what? Was equal to half times sine of the angle and times the two sides, which was KA times KA. Right? This was what was given. So that would be k square a square, and then here we have sine theta over 2. That is number 1. Now as we have seen for number 2, the area for number 2 was what? Was the whole area, which is half r square, the radius was a square of the angle, minus the area number 1, which is this one, k square a square sine theta. So let's equate that again. So let's see what do we have. So number 1 is equal to number 2. So on one side you will have k square a square sine theta over 2 is equal to number 2. That will be a square theta minus k square a square sine theta, sorry, over the value of 2. Now first thing, we can just eliminate those two values, right? Then we have a square on both sides, divided by a square. Everywhere you will have this will go away. Then you will have k square sine theta is equal to theta minus k square sine theta. Now let me send this over here. You will have k square sine theta plus k square sine theta is equal to theta. From this, we realize that we have 2k squared sine theta is equal to theta. So 2k squared has to be theta over the value of sine theta. Okay, so now we have seen this somewhere right here. So we know that this has to be more than 1. So from this, we realize that 2k squared has to be more than 1. So k squared has to be more than half. And as you guys know, we usually solve this by using the graph. So let's try that one more time. What you will have? K has to be, let's find the critical values. K has to be plus minus this value, right? So let's see, what do we have? According to, we have to look at this one. This is my value for half for now. This should be in this shape. This is the negative value, this is the positive value. For more than 0, should be this and this. Should be k should be less than minus root of half. K should be more than plus root of half. But given that k has to be more than has to be positive and more than the value and less than the value of 1, right? But it has to be positive, right? Because we understand that k is the length, because the triangle here, this side is k, so the length for the side of a triangle cannot be negative, so we cannot take the negative value, so we can only take this value. So k has to be more than root of 1 over 2. You can write this as your answer. So the set of possible values of k will be this for part B of the question. Okay, so that will be question number 10. Now let's move on to question number 11. The diagram shows the curve y. This is my curve y, right? That's the first thing we are given to you. And the curve crosses the x-axis at the point A. So this point A is the point where the curve meets the x-axis. Great. Now part 1, find the x value of the point A. So that's pretty easy. At the point A is on the x-axis. What do we know? At x-axis, we know that the value of y has to be 0. So just replace back in your equation. That will be 0, 9x power minus half minus 4x minus 3 over 2. So from this we realize we can divide by 9 everywhere. You will have x half minus 4 over 2 equal to 0. Now let's rewrite this. We can send this down. You will have 1 over x half. Send this to this side, it will become 4 over x 3 over 2. Now simplify by cross multiplying, or not, or we can just send this one over here. Make it easier. That become x 3 over 2 over x half. That should be value of 4. Now as you guys know by the laws of indices, we can combine those two. So x 3 over 2 divide become minus half. That should be x. That become 2 over 2, and that should be just x. So combine, this will give you what? X will be the value of 4. Okay, this is your answer for part A. So the point A is equal to 4, 0. This is the x value of your point A. Now for point B, find the equation of the tangent to the curve at A. So basically, we have a tangent at the point A, which is a line in this direction. Right? We have to find the equation of the tangent. So again, to find the equation of a straight line, what do we need? We need to have the gradient of the straight line. So we have to first find the gradient of the tangent. That's the first idea. Now, to find this, we understand that dy by dx is the same thing as gradient of a straight line. So let's first find dy by dx. So from here, we can conclude that y can also be 9x half minus 36x 3 over 2. Now find dy by dx from that. So let's see dy by dx. So dy by dx 1 by 1. 9 is only a multiple, so 9. We have to first multiply by the power. Then minus 1, that will be minus 3 over 2. Then here minus 36 multiplied by the power, that will be 3 over 2. That will be x, then minus 1 by the power, that will be minus 5 over 2. So all this will simplify to what? Let's see. That will be minus 9 over 2 x minus power 3 over 2, and this will become what? Let's see. So we have minus 36 times minus 3 over 2. That will be 54 x minus 5 over 2. So let me write this here. dy by dx will be minus 4.5 over x 3 power 2 plus 54 x 5 over 2. So let's double check this value again. So here we have 9 times 4 is 36, right? So let's check. 9 times 4 is 36 times the value of 3 over 2, that should be 54. Okay, should be fine. So now let's simplify. We have to find dy by dx at the point of A. So that will be dy by dx at the value of x equal to 4, right? That will be minus 4.5 divided by, so 4 power 3 over 2 is 1.5. That will be 8 plus 54 divided by, that is 4 power 2.5, that should be 32. So 54 over 32. So let's simplify. Minus 4.5 divided by 8 plus 54 over 32. That should be 1.125. Or you can write in terms of fraction. That should be 1 over 8, which is equal to 9 over 8. 1 times 8 plus 1 is 9, 9 over 8, right? That will be my equation, my gradient of the tangent. Okay, good. Now from this, we can find the equation. This is my gradient. My passing point is A, which is 4, 0, right? This is my x and my y value. So let's simplify. Y minus 0, x minus the value of 4 has to be 9 over 8. Cross multiply, that will give you what? 8y has to be 9x minus 36. And this is my equation of the tangent to the curve at the point A. Okay, so let's move on to part C of the question. So here I have to find the x value of the maximum point of the curve. So whenever you see maximum point or minimum point, we understand that we have to find dy by dx at the value of 0. So as we have seen before, dy by dx was given to you, was found to be, at least was the value was minus 4.5 over x 3 over 2 plus 54 over x 5 over 2, right? And we have to equate that to 0 at the maximum point. Now let's solve. So first thing we can do, we can send this over here. So you will have what? 4.5 on one side, and that will be x 3 over 2. That will be 54 over x 5 over 2. Now we can do something. We can send this here and send this down. You will have x 5 over 2 over x 3 over 2 equal to 54 divided by 4.5. That will be 12. 12 as your answer. Now for this one we have to simplify. Let's see. If you want to use indices again, that will be x 5 over 2. Here we have divide, become minus 3 over 2. That will become x 5 minus 3 is 2. 2 over 2 is 1. That will be x has to be the value of 12. So your answer will be find the x value of the maximum point. It is 12. And this is your answer for part C of the question. Now for part D of the question, so here we have to find the area of the region bounded by the curve, okay, curve, the x-axis, and the line, this line. So let's see what do we have. According to the diagram, this value here is 4, right? As we have seen right here. Now the line y equal to 9 should be somewhere over here. We can assume, right? It should be somewhere over here. That makes sense. This is my line y, so x equal to 9, sorry. That will be this one. Now we have to find the area bounded by the curve, the x-axis, and those 2 points. That will be this area. So how would you find this area? Pretty easy, by using integration, right? So the main idea was for you to understand what was the limits. So area will be integration between the value of 9 and the value of 4 for the curve y. Y, we have seen it could be written as 9 x power minus half minus 4 x power minus 3 over 2. This is given to you, so there's nothing to derive about this. This is just your equation of y. Right, now we have to solve this integration. So one by one, we can see this one is a multiple. We can just remove this outside for now and then integrate term by term. So here we have x minus power minus half. So first thing to do is to add 1 to the power, becomes half, divided by the power. Here we have minus, that will be 4 is only a multiple. Then we have to add 1 to the power, becomes minus half, divided by minus half. Okay, and that should be only 2 terms. Of course, we have to apply the brackets here, so we don't apply 9 to only one of the values. Now the limits have to be between 9 and 4. Again, we can just leave this outside for now. So for the first one, let's apply the power of 9. Now if you want to, we can first simplify, because it might be tough to you to simplify those values in your calculator. Let's first simplify. That will give you what? Divided by half will be 2 root of x minus 8 over root of x. Now there should be this value between the limits of 9 and 4. So replace, let's see what happens. So 2 root of 9 will be 2, 3 minus 8 over 3 minus now for 4 it will be 2 times 2 over 8 over the value of root of 4 is 2. Right, let's see what do we have. Solve one by one. So let's see. So 2 times 3 is 6 minus 8 over 3. That should be 3, 1 over 3. Now minus 4 minus 8 over 2. That should be 0. So now we have to multiply by 9, right? So here we have this. This is 9 here. So 3 over 1 over 3 times 9. That has to be 30. So your area will be 30 units square for this area. Okay, so here I was able to find a mistake. So basically what happened was when you divide by minus half, I forgot to put minus here. So that will become plus, that should be plus here, plus and plus. Okay, so this will not be the answer. So basically what's going to happen is you will have 2 times 3 is 6 plus 8 over 3 minus, that will be 4 plus 4, this times 9. That should be your answer. So 6 will be your answer at the end, and not 30, because as you can see, when I divided by minus half, I forgot to put minus here. So because of that, it should become plus here in the end. So let me rewrite this down. So from this you will get what? You will get 9 outside bracket. That will become what? 2 times 3 is 6 plus 8 over 3. That should be 8, 2 over 3 minus, that should be 4 plus 8 over 2. That should be 8. That will become 2 over 3 and times 9. That should be 70. Sorry, 2 over 3 times 9 should be 6. So 6 will be your answer at the end, units square. So again, you can see you should avoid those silly mistakes. And this is the last question of this paper. If you have any other questions, let me know in the comments. And either ways, I hope that was somewhat helpful. And thank you for watching. I will see you soon.